Alrighty, in this video, let's take a look at how you can set up OpenTelemetry for your .NET Core based applications to make your life easier when it comes to debugging the damn thing. My name is Vasily Olenik, I'm a senior .NET developer, and you're watching the Code Review series where I go through different interesting topics and best practices related to building applications with .NET Core. So, long story short, some time ago I encountered an issue with my favorite end-to-end tests inside a CI/CD pipeline, which started failing unexpectedly after an agent update. I had to spend some time to debug what the hell was going on over there, and the experience wasn't the most pleasant one. This and the fact that my current employee is looking into ways of enhancing its observability setup led to me writing down this video and diving into the topic of OpenTelemetry. The setup that we are gonna rock in this video is actually from the testing newsletter, where I cover different topics related to automated testing in .NET. So if you're curious about that, I'll leave a link in the description down below. But from a high-level perspective, this is actually what we will cover in this video. So we're gonna have a Blazor front-end web application, which has a couple of forms and interacts with the card game API. Essentially, this card game API will store the data in a MongoDB database, call an external notifications API, and also post some messages to the RabbitMQ queue. And we have also a consumer over here, which actually will pick up messages from the RabbitMQ and do some work in the background. The end goal that I traced initially was for me to be able to run the end-to-end tests and have an output which I can view and understand how the state of the application changed during the entire process. So I can debug those things in my end-to-end tests, and to enhance the overall observability of this small system, I took a look at OpenTelemetry. So we should also cover what OpenTelemetry is initially. Technically, OpenTelemetry is actually a framework, or you can also think of it as a toolkit that will help us generate telemetry data. Now, this telemetry data most often will take the form of logs, traces, and metrics that you are already familiar with. So, at a high level, the services that we are writing and the infrastructure where we are running our code can be instrumented either manually or automatically via OpenTelemetry. I am more in favor of manual instrumentation, since it allows you for way more customization, and actually it's pretty easy and straightforward to set up and get going from there. This manual and auto instrumentation will allow your software, which is the services and infrastructure, to push telemetry data to your observability backends, or to an OpenTelemetry collector, which will do the push to that observability backends for you and do things like batching, retries, data filtering for you, instead of you having to code that logic inside your software. Back to our setup over here, I'm gonna move my image out of the way right away. All our services are gonna push the telemetry data to an OpenTelemetry collector, and I'm gonna use two examples over here. I have in the code base an example where the OpenTelemetry collector is gonna push its logs to Grafana Log-Key, metrics to Prometheus, and traces to Grafana Tempo, and then use Grafana to query for all this data. But since splitting so many things up, recording this video and everything else is gonna fry up my small Mac, I'm gonna use a simplified Aspire dashboard for local development, which you can also use yourselves. I'm pretty opinionated about .NET Aspire as a whole, but the guys from the team did an amazing job building the Aspire dashboard, which we are gonna piggyback right on it. Let's take a look at the code base, and I'm gonna return my image over here. So to get started, we are gonna obviously need a couple of NuGet packages, and the main one that you will want to install is OpenTelemetry. And in my case, I have this OpenTelemetry NuGet package implicitly installed, since I have these packages in my card game store API. Once you have the packages in, we will want to take a look at our two things. Essentially, the first one is the runtime diagnostic config, where we have defined everything related to what our application actually is, and the OpenTelemetry installer that we have over here, where we wire up OpenTelemetry in our DI container. Back to runtime diagnostic config. Throughout our application, we're going to use this runtime diagnostic config static class to access our activity source, which in my case I have defined as a static name with .NET API. And also I've done the same thing for the rest of the consumer. We have a runtime diagnostic config over here with .NET consumer. For the web app, we have another one, etc., etc. Some people prefer to use this not as a static class but rather inject it. I prefer using this as a static class and not work with it via the DI container itself. That said, we have our activity source, which is in our case a .NET API. We have a meter, we have a service version over here for the meter itself, and a couple of metrics that we're going to implement a little bit later. So going to our telemetry installer, let's take a look at what we have over here. Essentially, first of all, I'm going to retrieve some OpenTelemetry settings, which if we take a look at it, is going to be a traces endpoint where we are going to send our telemetry data. We have a set of attributes that we are going to add to all the telemetry that we are gonna generate, all the traces that we're gonna generate. And this set of attributes is gonna be defined at the start of the application. So basically, you can add any kind of data in here that you think might be useful to have across your traces. Also, a flag if you want to disable OpenTelemetry, we'll get to that in a bit. And actually the telemetry attribute is just a key value pair that we can define inside the app settings. Now back to our telemetry installer, let me close this one. So we are gonna get the telemetry settings, we're gonna check if we want to enable OpenTelemetry. If not, we just short circuit it. And this here is actually an action that we are going to reuse across the entire thing. So we're going to build a resource builder with the specific service name from the runtime diagnostic config, with the specific version, with the service instance ID being the machine name. And here we start configuring our signals. So the first one is going to be logs, and there are actually two ways to configure logs in this setup. And essentially the first one is via Serilog, and it's native, you can kind of call it native support for OpenTelemetry, which is via the Serilog sync to OpenTelemetry, and you can configure it from the app settings like I did over here. So we're gonna go to app settings.json and see that, hey, for Serilog, these are the telemetry settings. So I have an OpenTelemetry name for the settings, and as arguments, I'm gonna send the endpoint where we send the telemetry data, the protocol, which in the 0 in this case, it means gRPC, and a set of resource attributes that I want to add to my logs. In my case, it's gonna be the service name, which is .NET API. So this is one way to configure logging, essentially via Serilog. And over here, I saw a small mistake. You can actually remove this part over here because we're reading everything from a configuration. This is probably some remnant of my POC work. The other thing is just basic Serilog setup. If you've seen any of my videos about logging, you should be familiar with how Serilog is set up. So it's basically services, adding a singleton, which is this logger, and then marking the host to use Serilog. An alternative approach, if you are not using Serilog, essentially, is via the default logging framework that we have in .NET Core. And we can do that by using builder, logging, add OpenTelemetry, and then configuring the whole thing. Now, in my case, you can see the telemetry and how I've configured it, and essentially also pass the traces endpoint, which comes from our OpenTelemetry settings. But since I'm using Serilog, I don't need this part over here. And next, let's take a look at traces. And over here, we can see how we can configure our traces. Essentially, it's going to be builder, services, add OpenTelemetry, configure resource, and use the action that we have defined on top of the configure resource to not rewrite all that code all over again. You'll need to add with tracing, and then you can start building your tracing setup from there. You're gonna need a couple of sources. So for tracing to actually work, you will need to pass in the activity source that you're gonna use. In my case, it's gonna be the runtime diagnostic config source and the name of that source. So essentially it's that static class that we have covered at the start of the video. Then also I'm gonna add another source, which is the mass transit activity source, because this API, the card game API, is gonna push messages via mass transit to RabbitMQ. And fortunately, mass transit does have OpenTelemetry support, so we can get additional information from that library. And we will also need a couple of instrumentation libraries that you can find under, if you go to OpenTelemetry and you type OpenTelemetry.instrumentation, and you can see a bunch of different instrumentation NuGet packages that you can install into your applications, like let's say Quartz, Hangfire, ASP.NET, Elasticsearch client, mass transit that we have already installed, gRPC, AWS, etc. And this will allow other parts of your system to emit additional telemetry data. Now, we will return to add processor in a bit. Once you have your sources and your instrumentation in place, you are gonna set up an OpenTelemetry exporter. In our case, I'm gonna use the telemetry traces endpoint from the telemetry settings, and I'm gonna specify that, hey, the protocol that we're gonna use is gRPC. And over here, there is something like a processor, and you might ask, what the hell is a processor? You can think of a processor as a way to transform your telemetry data. I'm gonna show you actually here a simple processor that I have put together, which is a simple value processor. And essentially what it's gonna do is gonna inherit from a base processor of type activity. So on start of every activity, we're gonna add a tag, with the key like static value. And the value itself is going to be static value to add to the traces. So across all our traces, every one of them is going to have this static value added to it. So this is a simple example of how you can set up a processor. And inside the telemetry data over here, I just have a simple link exporter that's gonna generate the links to our Aspire dashboard, so we can view it directly from here. So we don't have to navigate to Aspire dashboard and find the set metrics. We can just click through it over here. The next signal that you might need is actually the metrics, and it's really similar to how we've set up with the traces. You're gonna have a meter provider builder, you're gonna add some instrumentation libraries, which in our case is gonna be HTTP client and ASP.NET Core instrumentation libraries. You're gonna add up the OpenTelemetry exporter with the same similar setup, the same endpoint from traces, the same gRPC protocol over here. And you're gonna add a meter, which is actually really similar to how you use the sources. So the sources are actually what you want to track, basically where you want to track the activities from. And the same thing applies to the meter. Basically, this is where we want to track metrics from. In our case, it's going to be system runtime, ASP.NET Core hosting, Kestrel, runtime diagnostic config, the meter, which we defined in our runtime diagnostic config if we have custom additional metrics. And also over here, the instrumentation options and meter name, this is mass transit meter to get metrics data from our mass transit usage. That's mostly the basic setup that you are gonna rock in your application. So it's about 100 lines of code base to configure OpenTelemetry. Not that much if you ask me, but the gains are really immense. If we return a bit at the image with the OpenTelemetry collector, our services are gonna push telemetry data to the OpenTelemetry collector and or to third-party services. In our case, for example, Serilog might be configured to send logs to an OpenTelemetry collector and also use a sync for, let's say, Secu or console or any kind of other third-party services. So that's perfectly fine. Now, the OpenTelemetry collector is gonna take all the data and push it to an observability backend, and then you're gonna have some observability front-end APIs that are gonna make use of that data that the OpenTelemetry collector is pushing. The question here is if you want all your data to be pushed to the observability backends, or if you want to filter it out. Let's say you might not need to have thousands upon thousands of traces regarding health checks, because you might take only, for example, let's say 10% or 20% of that data and draw some representative graphs from there. You might want to actually register everything related to errors in your system, and for example, unusual behavior like some requests taking way too long. So that's actually the data that you want to look for. And if you have a bunch of data that it's really not needed there, first of all, it's going to consume a lot of space. It's going to consume a lot of network traffic because you need to push that data over the network. And lastly, you will have to filter out all the data in there. So how does OpenTelemetry approach that problem? Essentially, there are two things there. It's sampling and it's head sampling. So basically you filter out at the start of the request if you want to keep the traces from that request. So how does OpenTelemetry solve this issue? It's actually by the usage of samplers. So there are two sampling options, head sampling and tail sampling. Head sampling is all about defining at the start of your trace if you want to keep the information in that trace essentially, and tail sampling is the other way around. So you decide if you want to keep the traces at the end of the whole flow. Let's say you encountered an error, because at the start of the request you can't really know if there will be an error or anything like that. So tail sampling is where that shines. You're most likely gonna define your sampling stuff inside the OpenTelemetry collector, but there's actually a way to define head sampling in our applications. So over here I have a small example of how you can set up sampling, which I have commented out, but you will need something like this. You'll have to set the sampler in the tracing part, but also in my case I have a simple setup over here where I use a singleton, which is actually user tiers. So I define a couple of user tiers over here, which is actually basic tier, standard, and premium, and define a couple of percentages. So for premium tier it's 15, for standard 10, and for basic tier is 1%. These numbers are the percentages of how many traces we are gonna save for each type of user. This is actually not a really real world case, but it's really good for a POC example because you can see different things in there. So going back to telemetry installer, you can see that, hey, we have over here an always off sampler, and there are two different samplers. There is an always on sampler and always off sampler that you can make use of. Let's go to the custom check sampler that we have implemented over here, and it will make it a little bit easier to understand. Over here, I'm making use of the DI container to inject specific things. In our case, it's the user tiers configuration and the HTTP context accessor to retrieve the type of the user from the headers. And essentially also there is an inner sampler that you can think of it as a middleware and how middleware works. So we're going to inject in here a sampler, which is going to be the always off sampler, and we're going to use this inner sampler in a bit. And when we go over here, it makes it a little bit more clear. So we are going to retrieve the user tier from the HTTP context. And in case the user tier is null, we are going to set that, hey, we don't want to save telemetry data about those users. So we're going to make use of the inner sampler, which is an always off sampler by default. You might want to have, for example, an always on sampler and in some other use case. And this one, we don't want telemetry data from non-authenticated users or users that do not pay us any money. So we don't save telemetry data for those users, which is actually a really bad business case, but hey, it makes sense in the POC world. The next thing is based on the user tier and basically on the percentage, we define that, hey, if we should sample the data that came in and basically assign it a Boolean value if the keep percentage is bigger than the random part over here. And in case we should sample it, we can use, for example, and add additional attributes in there. So we might want to use an additional tag and basically add the user tier in there to make sense that, hey, this sample is for a specific user tier. And by the way, try to use as much as possible constants so that your tags are the same across all your applications. You can share those tags, let's say by NuGet packages, or have some documentation pages, God forbid, where you define all those tags essentially, because that will make your life easier from when you'll have to configure dashboards, alerts, etc., etc. And over here, once we decide that, hey, we should sample this trace, we basically return a new sampling result, and we just record and sample, and also add the sampling attributes that we want to this trace. In case not, we're just gonna return the decision to drop this specific trace. Going back to telemetry installer, let me remove back the comments, and yeah. And with this, it's actually everything that you need to configure in order to add telemetry to your web application. In my case, I have the same setup or a similar one, let's say inside the card game consumer, and over here we have runtime diagnostic configs with the .NET consumer part over here, and also telemetry installer that actually looks pretty similar to how the card game store API one is set up. Essentially, this one is the more extensive version of the other two, because this actually consumes only one message and this has a couple of forms. The API itself is the one that does the heavy load over here. Quick shameless plugin here. I also have an entire course dedicated to building Modular-Monolith or microservices ready applications. If you want to check that out, I'll leave the link in the description down below. 20 minutes inside the video, let's take a look at how this all things run actually. To do that, I'm gonna go to the file system view over here and run my Docker Compose files from here. For starters, I have a Docker Compose for all the services in here, so I'm gonna run a Docker Compose up for all these services, and I have two different Docker Composes, one which is for Grafana with all the setup in place over here, and one which has the Aspire dashboard and an OpenTelemetry collector, which actually takes the configuration from the OpenTelemetry collector config for Aspire, so it's already configured to send telemetry data to an Aspire dashboard. Now, if I close all of this and if I go to my Docker over here, you can see that everything has ran up, and from here we can go to our dashboard, and probably there should be a couple of logs already. Yeah, so you can see that our web application has already started logging data. Now, if I go back to this page over here and navigate to the web app, you can see that over here we have a card game form, which sends data to our web API. So if I type in here card game code, well, actually, this is the name of the card game, and the code, let it be IGO. I'm gonna submit this form. Now you can see that form submitted successfully. We can go to our Aspire logs. You can see some data in here. But if we go to our traces, which is the most important part, we can see over here a request that has been made, and essentially a couple of sources for where the traces are coming from. In this case, it's gonna be the web app. Has two traces, the .NET API and the .NET consumer that picked up the message generated by the API. If we go to the view part over here, you can see the whole trace waterfall, let's say it, and this is basically how the entire request went throughout my system, and this is actually the thing that I was looking for to have when I was debugging the end-to-end test issue in the pipeline. If we click on any one of those, you can see that, hey, we have our .NET web app, and this generated trace. It sent a post request to the post card game part over here, and essentially it hit the API v1 card games. I'm using mediator, so this triggered card game command. Essentially in there we have a couple of repository methods to get async, and if the card game is not found, it's gonna create that card game. And I believe if I click on create card game async, you can see that here we have also added a simple event, which is just called card game created. And essentially then after the create card game async is finished, we're gonna put a message, which is a card game created on the message bus via mass transit. And over here you can see that we have all this data that comes from mass transit regarding its usage, and also the .NET consumer that has picked up that message and has done some work in the background. This is basically just a 2 seconds delay over there just to emulate some kind of work in the background. Now, you're not gonna get everything in here out of the box. So all these activities that you have defined, that you can see over here, some of them I have defined them manually in my code base, which is why I love the manual SDK. So if I go to the solution and close everything in here, we can go to our application, card games, commands, create card game command, and we can check how I'm making use of the runtime diagnostic config to create different activities. So in here you can see that, hey, I have created this, I have triggered this create card game activity by going to the runtime diagnostic config source start activity and then the name of create card game command. Also, this is actually the approach where I decided, hey, I want to add additional data to my current activity, which in my case is going to be the name of the card game and the code, because I might make use of that additional data when I look for understanding the state of the current application at a specific time. And I'm making use of some predefined tags, which is actually just hard-coded strings. The next part is repository get async, which essentially in itself is going to have another activity that started similarly to this. And in here we can actually get the current activity, which is coming from this repository get async, and add an event to it in case we have already found the card game in our database. Otherwise, it's basically just repository create async, which is interesting to us to go to the implementation here. So essentially we are creating a new activity, and if you don't pass any kind of name here, it's going to take the name of the method that is currently running or the current activity, and essentially add trace information that, hey, we're going to insert card game into the collection, and also add to the current activity a new event, which in our case is going to be card game created event to our activity. Now going back to the command, once the message is published, from over here, mass transit is going to take care of adding the telemetry data and then pushing the message to the RabbitMQ. Finally, we return a result OK to the end user, which is actually why you see that, hey, the initial trace parent has finished over here, because over here we have returned an OK response to the web application. But actually in the background, this whole flow has run for a certain period of time. So it's not necessary that your initial request will be the entire duration of the entire trace waterfall. You can have stuff like this happen also, and in asynchronous systems you might have similar situations over there. Now comes the fun part, how we can make use of OpenTelemetry inside testing. I'm gonna close everything in here since we don't really need all that stuff, and close the card game store API and return to the tests that I have defined for this solution. And here, if you followed along with the newsletter, we have contract, end-to-end integration, Subcutaneous, unit, and contract tests, basically all kinds of testing. And let's take a look at how we can leverage OpenTelemetry to get information from here. First off, I'm gonna go with the unit test since it's the easiest one to set up and to explain the setup itself. When we are running our web API, we have this runtime diagnostic config that we have configured. So basically we have a source that generates telemetry data. When it comes to unit testing, we don't really have that source defined. That's why we're gonna need to define a source. And to do that, we're gonna need a couple of extra NuGet packages. I have tried to do that myself without those packages, and it's doable, but it's an entire crusade to get that working. So to get started with OpenTelemetry inside xUnit, in our case, I'm gonna use the practical xUnit OpenTelemetry NuGet package, which is created by Martin Waits. We're gonna use this package to instrument our unit tests. Next, to get started, all we will need to do is define this OpenTelemetry framework class, which will inherit from traced test framework, and essentially behind the scenes rewrite a little bit the behavior of xUnit. And over here, define your trace provider builder. In my case, I'm gonna add up a service which is called card game store tests.unit. I'm gonna add a source which is unit tests, and this source is actually will be defined inside my application unit tests, inside my unit tests. If I want to add additional trace information, which is going to be used in cases I want to add additional activities from within the tests themselves. And also I'm going to add the source, which in my case from the API, which is the runtime diagnostic config source name. Otherwise, if we go to, I don't know, application, we have over here the activity source, which is actually unit tests. And for example, over here, I have started a weird activity, some test run, just for POC purposes. But other than that, if we go to architecture tests, let's say test base, nothing changed over here, nothing changed inside our layers. So the OTEL framework is all we need to actually add to the xUnit to make use of OpenTelemetry. To show you the results, we're actually just gonna build the selected project and then run the unit tests themselves, which should appear over here. And once the unit tests have run, going back to our Aspire dashboard, I'm going to go to traces, and here you can see that, hey, we have a new source, which is actually the card game store tests.unit, and essentially over here we have traces from our unit tests. Where things get hazy is inside the integration and subcutaneous tests, and this is most likely an issue that you're not going to encounter in other languages because this is .NET specific, and is the fact that inside integration tests and subcutaneous tests, and if you've watched any kind of my video regarding the integration testing part, we are spinning up an instance of the web API per test class. Normally that shouldn't be an issue, but when it comes to OpenTelemetry and in .NET, OpenTelemetry uses the activity source behind the scenes and activity listener, which live across the whole app domain. Now, typically this won't be an issue because we are running a single process. But when it comes to integration testing, since we are spinning up multiple instances of our web APIs, we're gonna use multiple activity sources, and your spans, if not done right, are gonna get duplicated or tripled depending on how many instances you're running currently. So to avoid that, we will need to add the same OTEL test framework in here, and that's basically the setup for xUnit over here. So it's the same thing. We're gonna configure the resource. In our case, it's gonna be card game store test.integration. Also, we're gonna add HTTP client instrumentation. I'll return to it in a bit. And adding the source, which is runtime diagnostic config source name. Now, to our problem with multiple instances of our web API sending telemetry data at the same time, if we go back to our card game store API in the installer itself, you remember this disabled field over here. This is essentially my way of circumventing that issue, because in the test in the web application factory, I'm gonna set up an environment variable that will translate to this configuration part and tell that, hey, this instance of the web API does not need to run telemetry data from within the telemetry installer, but rather make use of the OTEL test framework and get telemetry data from this specific resource over here, which is going to be the card store test integration. And I'm going to add HTTP client instrumentation, ASP.NET Core instrumentation, and the source from the web API. Basically, this is the activity source that we're going to trace, and the OTLP exporter, which is going to send the data to our Aspire dashboard. Now, behind the scenes, I've cleaned up the Docker to retain only the Docker dashboard, the Aspire dashboard and the OpenTelemetry collector to make the life easier on my machine. And if we go to infrastructure, the API factory, I'm gonna show you really quick the setup in here. So we have our create host method, and before the create host even runs, the base method, we're gonna set up the environment OpenTelemetry setting disabled to true. Now, technically with this and the HTTP client instrumentation that you have from .NET 8, you should be fine to go. But in my case, I was not able to send traces data from the test run. So essentially I was getting only the data from the API itself without the name of the test and all the test information that I required. So I had to do a small roundaway. So if we go to endpoint testing to card game, create card game tests, in here we have an HTTP client generated by our API factory, but with a different method, which is get enriched API client, which actually just creates an HTTP client the default way. And if the current activity is null, it's going to return that HTTP client. If not, it's going to take the current activity, which in our case is going to be the test itself, and inject data about that activity through the OpenTelemetry test framework propagator, which we have defined in our static class over here. And it's a default text map propagator. And we're going to use it to inject additional information, basically inject the information about the trace parent into our HTTP client and send that data over to our API. The end result will be something like this. So if we run this integration tests, open the unit test, it's going to spin up a couple of Docker container instances and run the test. So fast forwarding, this will result in data that looks like this. And if we go to our card game store test integration, we can see our first create card game endpoints test. So given valid card game, it's gonna create the card game, and we can see that telemetry data that we have out of there. So our integration part has called our API v1 card game with this specific data. Then it has created the card game, and we also see the cleanup part in here as part of the same test. And if we go to other, so we have over here given a fail by default has fail, and we assert for its failure, and we can see that, hey, the integration part with the internal API has an issue over here. We can also see that exception at the level of trace parent. So we have a card game store infrastructure notification with a stack trace with the message, etc. Basically, this is the setup that we are getting from the .NET, the practical .NET testing telemetry from Martin Waits. Going back to our tests, For Subcutaneous tests, which is actually pretty copy-pasty thing, it's an open telemetry test framework, but with just a different source name, which in our case is Subcutaneous, and just the ASP.NET Core instrumentation, since we are not using the HTTP client. We're getting the stuff that we need to test from the DI container itself. Last but not least is the end-to-end part and the goal of the whole thing. And these are actually the easiest ones to configure, since we don't have to do any kind of mumbo jumbo jumping around with the test framework, etc., etc. We just go to our test context, which we have created previously, and in here we have just defined a new Docker Compose file that we are gonna run as part of the entire end-to-end flow. So I'm just gonna put a breakpoint before dispose async, before disposes of the container, and debug this specific test, which is gonna spin up some containers behind the scenes. So it's spinning up all the infrastructure parts, so RabbitMQ, dashboard, notifications API, card game, and everything else, and running the end-to-end tests via Playwright. It should probably open an browser window over here. As you can see, it's filling in the data, submitting the request, and once the breakpoint has been hit, we can go to our Docker and here navigate to our dashboard, and we can see all the telemetry data from our applications with the traces. In our case, it's going to be this one where we are interested in our .NET Web API, web app, calling the web API, and we can see the traces just like previously. We can see that the web app has sent the post request to the API, and we can trace everything else regarding what and how this test has been run, as well as the metrics for our web application, for our web API, for our consumer during the test run, and then basically take up all this information, the structured logs, the traces, the metrics in from our test runs, see if we can make sense of the state of the application during the test run, and maybe we need to add additional information in there to make our life and or basically debugging experience on production easier, because this is bona fide how you're gonna run the application in production and how it's gonna behave as close as possible to production-like environment. If you like this kind of content, leave a like, comment, subscribe to the channel if you have not already, and click the notification bell so you get notified whenever a new video comes up. By the way, as I said, everything in here comes from the newsletter that I'm running about testing practices. So if you want to grab the code behind all of this, there is a link in the description below where you can check also the newsletter and read some interesting stuff about testing in general.